Here's a little quick tutorial on the mean value theorem. I know a lot of students kind of don't understand this and have a little trouble identifying with it and using it, so we're going to talk about this right now. So the mean value theorem, if you find in a textbook, or in a calculus book, says if y equals f of x is continuous, I can't spell continuous, right? Continuous on every point of a closed interval a to b, and differentiable at every point of its interior open interval a to b, then there is at least one point C in AB in which this occurs, where the derivative f prime of C will equal f of b minus f of a over b minus a. Now we know that f prime of C, this right here stands for the slope of a tangent at x equaling C. This right here is going to be a slope of a secant line passing through points A, or x equals A, and x equaling B. All right, so what we're basically saying is that we're trying to find out where a slope of a tangent line equals the slope of the secant line on a given interval from A to B. Now, what does this mean? What is this really saying? Well, let's do an example. I think this will probably help us out. We have this right here. It's our function. I've graphed the function over on the right, and you can see that. Now, what we want to do is we want to use the mean value theorem to find the value C on this open interval from 0 to 1. So, essentially, what we were doing is we're trying to find this line, this secant line, and I'll draw a dotted secant line, from 0 to 0.1, wherever that may be. Now, it appears that it will be maybe this horizontal line, it could be, or this line, and I'll make it right there. But it is passing through this point at 0 and this point here at 1. Okay, so we're trying to find when does this line equal the tangent line. Now, if the slopes are equal, that means the lines are parallel. So we can kind of estimate this and identify that, okay, this secant line will probably be parallel if I can go right here and take this, let's clone this puppy. All right, and I can move this, I can see, okay, this can be parallel right around here. Okay, at this point, right as we look, point of tangency right there. So somewhere between 0 and 1, we can see that. Maybe that's 1/2 or whatnot. So to find this out analytically, we're looking for this C value. This C value, this point of that point of tangency. All right, where that's going to be located. So in order to find that, we're going to first find f prime of C. F prime of C is the derivative. Okay, so we can find out what the derivative of the slope of the tangent line is going to be. So we have negative 2x plus 3x squared. After that, what we're going to do is now we need to figure out what the slope of that secant line is, because this is the slope of the tangent. All right. So now we're going to take and find the slope of the secant by taking 2 points on it. So we're going to plug in f of 1 minus f of 0 over 1 minus 0, which is 1. And so what we have is plug in 1 there, we get negative 1 plus 1. All right, minus, plug in 0, we get 0. And it appears that right there, that is going to equal, yes, 0 over 1. So they happen to be the same. Okay? So what we have right there, it's going to be a slope of 0. So it is actually horizontal. All right, so my graph is a little bit off. Okay? So what we have right here is, when we take that and we're going to find out when does this equal 0. So when do we have a horizontal tangent line that's going to equal that horizontal? So I'm going to just change that right here, so make it horizontal, like that. Now obviously this is going to be horizontal as well. It's going to be like that, about the same spot. All right, so two parallel horizontal lines. So let's solve for x now. Or actually solve for C. I apologize. So we're solving for C now. From here, we can factor out C. When we do that, we have negative 2 plus 3C equals 0. And so when does this equal 0? Well, when C equals 0, or when C equals, what is that going to be? 2/3, and that's what we have. Now, we make sure that we check our answer with our open interval. And we see that our open interval is between 0 and 1, so obviously 0 won't count because it's not on that interior value. Let's see at 2/3, and we checked to verify that that does make sense. And actually, yeah, that's pretty close to 2/3, about 2/3 away from 1. So yes, this is where we have that horizontal tangent. Okay, at c equaling 2/3. You can find these equations several different ways by using that slope and that point, but that is how we use the mean value theorem. Once to recap, the mean value theorem allows us to find where a slope of tangent equals the slope of that secant line, where the two lines are parallel. All right. By doing that, we just set the two slopes to each other: secant and the tangent, the derivative, and our average slope. All right. So that's the mean value theorem. Enjoy.